we work this? With, we want to do minimum effort. Another reason apart from minimum effort is many times you get code available, let's say on GitHub or from a collaborator or a colleague, right? You want to make use of it with minimum modification and editing, right? So this is another motivation for working this out, okay? So let's see how to work this out. So what do we need in a CG method? We need starting point, which is my P0. I need from P0 to get to x1, what do I need? Alpha, okay. From alpha I get my next x1. Then what do I need? I need to get the next P1. To get P1, what do I need? Beta, right? So if I get a few of these parameters correct, I know the rest of the sequence. So let's work it out correctly, okay. So the first thing is the conjugate directions, okay. The conjugate directions obviously of A hat will be different from the conjugate directions of A. There is no reason why they should be the same. And we have to also ask whether or not they are conjugate, right. So let's see what is the relation over here. So Pi transpose A hat Pj hat, okay. Right. This obviously should be equal to delta Ij, that is what we want. So let's substitute over here. A hat was simply L transpose AL, right. So this becomes delta Ij. It is 0 if I is not equal to j, right. This is the Kronecker delta. Are they orthonormal or not? Need not be. They can be some. Are they orthonormal? I am saying need not be. So you can have some factor over here, tau I or something. Doesn't matter. Not important. Right. So if I just wanted to make sure that everything went ahead as before, what would be the most obvious choice of Pi hat? Right. So if I make, right, so if I made this equal to Pj, right, and this equal to Pi transpose, I'll automatically make sure or ensure A conjugacy, right. Therefore, Pi hat, sorry, Lpj hat is equal to Pj. Okay. So the new conjugate directions are simply L inverse times the old conjugate directions. Okay. So that was one easy thing out of the way. By the way, it currently looks like I need to evaluate L inverse. You should be suspicious of any method that asks you to invert a matrix. So later on we'll come back and see, do we actually need to calculate L inverse? Okay, right now it's just in symbolic form. I've written L inverse. We'll see whether we need to calculate it. Okay, then let's look at the residual. Okay, so Rk hat will simply be A hat x hat minus B hat. What should this be? Exactly, right. This is going to be, maybe we should just write it out more explicitly. So this is L transpose AL. X hat was what? Look back at your notes. X hat was it Lx or something else? L inverse x, and B hat was L transpose B. So if I take L transpose common, what do I have? Ax minus B, L transpose Rk. Okay. So the new residual is given in terms of the old residual, and there is a factor L over there. Okay. What about alpha k hat? So if you look at we had a simplified expression for alpha that we had derived, which was this was the expression for alpha. Right. Now we already know p hats and r hats in terms of the old guys. So rk transpose rk hat, I mean rk hat transpose rk hat, what would that simplify to? What is rk hat transpose? Can I write it in terms of the old r? See, I want to get all the new expressions in terms of the old expressions as much as possible. So I can substitute from 2, I am going to get rk transpose L transpose rk. What about the denominator? pk transpose apk, it remains the same. Okay. So this expression looks a little different from the original expression. The original expression obviously did not have a LL transpose hanging out there in between. So this is the first difference that we notice. Let's see how we can resolve it. Next, what do I need? I got my P, R, alpha. What else do I need? I need my betas. Right. So let's look at beta k. Let's say beta k plus 1 hat. Okay. The simplified expression for that was rk plus 1 hat, rk plus 1 hat divided by rk hat transpose rk hat. Right. This is very similar to step 3. I am just going to get a LL transpose rk divided by rk transpose LL transpose rk, right. So you notice that both alpha and beta have a kind of a funny thing happening, that this LL transpose is being introduced somewhere. And if you remember our CG routine, I needed the values of alpha beta to go ahead next, right. So these two guys seem to be little bit different, but the difference has a pattern, and the difference is the appearance of this LL transpose is always being accompanied by the residual term. Okay. So the clever thing to do would be, at this point I introduce a new variable. Let's call this LL transpose RK to be a new variable. Let's call it LL transpose RK is equal to YK. So having done that, what happened to my alpha? This became RK transpose YK by PK transpose APK, and this became RK plus 1 transpose YK plus 1 RK transpose YK. So at least there is a simple looking form that is coming up. Okay. So I have got my alphas, betas. I need to now know how do I go to the next conjugate direction. Right. So that let's say 6 is so pk hat, I write it in terms of minus rk hat plus beta k hat times what? The previous conjugate direction. So pk minus 1 hat. Okay. Now pk hat was what in terms of the old p's? L inverse. So this is going to be L inverse pk is equal to, now rk hat was what? L transpose rk. So this was minus L transpose rk. Beta k hat, let's leave that as beta k hat because I have an expression for it, and pk hat was again L inverse of pk minus 1. What do I do here? Multiply by, left multiply by L. Okay. So that is going to give me my pk. So minus L, there our friend appears again. LL inverse cancelled off, right. So I am basically, this is the new relation I get is Pk is minus Yk plus beta hat k Pk minus 1, right, not bad. So this is sort of telling me that even though I have the new system, hatted system, A hat, X hat, B hat, my update equations I seem to be able to work with my PKs, but with the exception that there is one new guy Yk floating around, right. Now to confirm whether all of it goes through, I need to look at step 1. Step 1 is the first conjugate direction, right. So what is P0 hat? In any CG method, P0 would be minus R0, so this is going to be equal to minus R0 hat. Now, P0 hat is what in terms of the P0s? L inverse, right. So, this guy is L inverse P0. What is this guy? R is L transpose, so minus L transpose R0. Okay, so these are obviously equal. So, this implies what? P0 is equal to minus LL transpose R0, there it is again. So, this is minus Y0, okay. So, I have got my P0. The final piece of the puzzle is how do I go to the new X, right. So, let us look at that. New X is going to be that is my expression for, right. Now, what is X hat in terms of L? X hat in terms of L? Is it L or L inverse? L inverse, right. So, this is L inverse xk plus 1, L xk. Alpha hat, I have an expression, I am going to leave it, and P hat is again L inverse Pk, right. So, basically I get the same expression. Okay. So, that is quite interesting, right, because what is it saying? Let's just try to recap from the beginning what we did. We started with a new system of equations which was A hat X hat is equal to B hat. So far we have not spoken about how do we get L, but let us assume we have it. Then we saw that after having done all of this algebra, the starting direction P naught was simply minus Y naught, which looked similar to the first CG step, right. After P naught, what did I next need to do? For example, to get to the new X, to get to X1, what would I do? I would use relation in 8, because I have my P naught, I have my alpha hat expression also, I have my X naught, I get my new X. From equation 6, I get my new P's, I know how to update my P's, right. And these are all the original P's of the original A matrix. I have not had to recompute or do anything. These are the original P's that were there for the bad condition number, except everywhere we notice that there is one new variable hanging around whose name is Y. So, there is obviously there is no free lunch. The price that I am paying is you need to compute this guy, right. So, the price that I have to pay is if you just look at that. So, that is our LL transpose RK equal to Y. LL transpose RK is equal to YK, okay. Did we ever have to calculate L inverse? It appeared as an in between step, but we never actually needed it anywhere, right. Everything was up, the only extra term was this LL transpose appearing everywhere, right, okay. So, this needs to be done, right. Now,